Well, hello everyone. Now we have two great speakers about two very general topics which I think every lead dev needs to know about. But now we are speaking about databases. So how many of you here loves databases? Oh, wonderful. And how many of you here hates databases? About the same amount. Well, anyway, I appreciate what so many of you at least are impartial to databases, which is important. And in this talk, we are going to talk about what is going on with databases at this time, with my focus on open source databases, of course. Now, how many of you here use some open source? Well, good. How many think that the open source is a good thing? Okay. That's good. You're my people. Okay. So let's first start with innovation components about databases. What is really changing in the last few years, maybe a last decade? One is what we are increasingly moving to the distributed databases, right? Databases which are built in from the ground up to be distributed databases rather than databases which are built for a single machine, right? If you think about Oracle or MySQL or Postgres, all of those have been built with the concept of running on a single, maybe quite beefy server. The next concept is the separation of storage and compute, which is especially enabled and possible in a cloud. And what that allows us is to say we can scale our computational resources for our distributed databases separately from the storage resources, right, which really empowers us to have a lot of flexibility as well as enable serverless databases, right? Because if you think really about the serverless, about the multi-tenant serverless database, then you can say, well, you know what, if a database is not really used, it's kind of not really spinning and using compute resources, well, then you better have a separation of a storage and compute, because you may well have some large amount of data which you may want to query, but maybe you just query that irregularly, right? Maybe you have something you have to store for compliance reasons, and then, you know, query it only if a request comes in, and hopefully that request doesn't ever come. Now, one thing to note also here, of course, the serverless is a little bit of a misnomer term. I think especially with databases, you still have somebody has those servers and storage systems, right, which takes care of your data. But at least that speaks to architectures when you, as developer, don't have to care about the servers and instances, right? You know more provision, well, I provision 5 instances of 32 gigabytes each or something like that. But you just think in terms of their, you know, performance, maybe data size, and so on and so forth. Here are some of their modern developments in this space. One I would mention specifically is Neon. There is a very young startup which took the leading open source database, Postgres, and they are building their open source cloud native serverless solution on the top of it, which really is able to separate that storage and compute as a part of the architecture. The other company I would mention, also very early startup, is Tigris Data, which is focused on another important pattern which we follow in databases, is really trying to minimize amount of work developers have to do administering, configuring, and so on of databases, right? Because that is something which is typically not very productive for building your application as fast as possible. Another big change over the last decade or so, I would say, is really arrays of databases which provide us a lot of different interfaces and data models. Right? If you look at something like early 2000s, then majority of databases would be relational databases. If you think about property databases, Oracle, SQL Server, DB2, whatever, or open source databases like MySQL and Postgres, right, those would be relational databases. And now, relational is only one of the choices, right? We have document databases, time series, graph databases. You have something which is, have us like a flexible data structures as Redis, and so on and so forth. What I think is also interesting here is what many databases are moving in that kind of multi-model concept, when a single database may allow you multiple models to operate. And I think what is interesting here is what move goes kind of in both direction. On one extent, you can see databases like MySQL or Postgres adding improved support for JSON, and even maybe some different interfaces than SQL, right? For example, MySQL has the doc store protocol, and not even on the open source databases, like Oracle, for example, as well, recently added support for MongoDB protocol, right, if you like. But also it happens from an opposite direction as well. If you think about databases like Cassandra or Elastic, which are not relational databases, they add either direct SQL support, or Cassandra have CQL, like a Cassandra query language, right, which kind of borrows a lot of concept from SQL. What we also see is what many technologies are also even support multiple protocols to a point they pretend to be something else from application standpoint. For example, if you look at ClickHouse, like this is their an open source analytical database, if you don't know. Additionally to the native ClickHouse protocol, it can also speak MySQL or Postgres. So if you just have your application being able to connect to, let's say, PostgreSQL database, you can connect to ClickHouse and just start running queries. You do not need to figure out the, the other connector type to use, right, in your infrastructure and so on and so forth. Right. Victoria Metrics has a different storage APIs as well. That is a time series database. Now we also have some tools with different names. For example, FerretDB allows you to use PostgreSQL as if it were a MongoDB interface, or Babelfish turns the same Postgres in Microsoft SQL compatible database. And again, those are all open source tools which you can just check out if that's something you're interested in. So that is technology side. Now let's talk about their open source side and what is happening in this case, because there is a lot of interesting things here as well. So what do you think the biggest factor which impacting open source now and has been for the last few years? Anybody? Come on, just shoot. What? Money, yes. It's always about money, right? But yeah, well, I would call it in a different word, but it is connected to money. You're absolutely right. It is cloud, right? Really, cloud has been very impactful to a lot of things in how we are doing business, developing applications, and so on and so forth, right? And open source is impacted as well, right? And to the point, for many years, we had the leading open source databases, right? Fastest growing and so on, so where the open source databases. In the year of 2021, it was Snowflake instead, like the proprietary cloud-based database, right? Here, by my plan, I was supposed to insert some nasty swearing in German, but organizing asked me to keep it at the PG level, so you can just understand what I mean. So how does cloud impact their open source databases? Well, I think it's interesting. On one extent, it really helps you to maximize adoption and make it kind of very fast, right? If you're thinking about where open source project cloud can, and it is really solved some important need, cloud can really accelerate adoptions very well, but that also challenges opportunities for monetization. Because that means that cloud vendors, like hyperscalers, which have a lot of leverage, advantage out there, can take your products, shrink wrap it in their cloud and make it accessible, right, and make all the money. Now, what's important here, though, to remember is what if you think about open source and money, what the open source itself, like the open source movement itself, was never about the money, and that is not really the business model on its own. Open source can enable many different business models, right? And those are changes with a cloud. For example, some companies, they're relying on an open source GPL license, which says, hey, you know what? If you guys need to run build a proprietary software and include our GPL code, you can do it, so you have to pay us license, right? If you want to play non-open source game, let's do that, right? But if you are on the open source side, then you can just use our GPL software for free. Well, cloud kind of hijacks that, because GPL takes in place only if you're doing distribution of your software, and there is no distribution in the cloud. When somebody like Amazon can modify MySQL, call it Amazon Aurora, and make all the money, while Oracle still has to do a majority of their MySQL development. Now, I think what is interesting here is what that is where how the open source is governed becomes very, very important. And I think we are increasingly will be looking very much separately at this, foundation-driven open source versus like corporate or like single vendor-driven open source. Because if you think about the foundation open source, they really love to see what the cloud really accelerates. Open source makes it accessible to so many users, right? And in fact, what the list of their donors changes doesn't really bother them so much, right? Think about the PostgreSQL community, right? PostgreSQL, I think, really has been growing so rapidly in the last few years because of a cloud. Because many developers, they love the Postgres. It was an amazing database with a lot of features. But a decade ago, they often couldn't really use it because it was hard to maintain. You would require some very skilled DBAs to do replication, have ability for Postgres, and so on and so forth. Guess what? With Heroku, and then later Amazon, RDS, and others, those problems went away. Right? If you're running PostgreSQL in the cloud, you can use all the development goodness, but you can have somebody else to take care about those other things. Right? And then in the single vendor standpoint, of course, those tends to be large venture funded and public companies, right, which dislike that competition with the cloud vendors, and they're typically, business first, open source later, and that is why we have in this space a lot of companies recently have fully or partly abandoned their open source licenses. Right. Now, if you think about those folks, what is the goal of the license changes? Right. Probably many have not followed that specifically, but it is really creating monopoly, especially in the database as a service market, right? Some folks also call those licenses as a non-compete license. It's saying, hey, you know what, you can almost use it as open source license unless you are competing with us. Now, if you think about that database as a service, and say, hey, you know what, They don't allow us to use database as a service, right, or use only kind of proprietary version from that vendor himself. Why would that really matter? And that would matter because database as a service is what gives us that state-of-art simplicity of using a database. That is what provides a high level of automation and maximizes developers' focus on their application. Now, what is a problem, though, of this database as a service monopoly? Well, I will say that is twofold. One is what we see increasingly as more and more developers start to use, and a team start to use database as a service, you have a lot of people who do not have the skills anymore to run like a real open source database, right? Well, at least in the US, right, where I come from, often when somebody tells you, oh, you know what, I know Postgres, well, that means they know how to, deploy Postgres a few clicks on Amazon, right? That not really how to set it up from the ground up. And also, that makes things really not different from a proprietary software. Right? If you only can use the database as a service, kind of shrink-wrapped open source, which only comes from one vendor, it is no better than Oracle. You are still a hostage more than a customer. And I think that really applies to the general concept of clouds, in especially those highly proprietary technology in cloud vendors, which often offer us great usability, but that comes at a great cost, both for literal cost as money, as well as cost as freedom, right? Freedom from vendor locking. But now I think there is not as lost with the cloud in open source space. And somebody, as have been in open source from its relatively early years, that reminds me somewhat like early 2000s, right, or maybe late 90s. When I would remember we have folks on a Microsoft and Windows stack developing .NET. We have those kind of wonderful, sexy tools and GUI, right, compared to us, open source dudes who would write PHP code in VI, right? Or I remember on my system administration side, we have folks running a real operating system, Solaris, HPUX, AX, right, joking about Linux. What the hell is that, right? I mean, 32-bit, bad support for SMPs. You could not even have files more than 2 gigabytes in size at that point in time. Now, of course, that is all forgotten together with Solaris, HPUX, and IX, right? And Linux kind of eliminated all those limitations. And I think that is what we're likely to see in the cloud space as well. There we have increasing work going on in what is called like a cloud-native space, right? A lot of open source work out there, a lot of projects focused on the Kubernetes and Kubernetes ecosystem. And I specifically wanted to zero in here, right, or maybe kind of to include this slide showing the ecosystem of cloud-native landscape. You can see there is a ton of companies and solutions. In many cases, there is really kind of too many. Like similar actually to Linux, you would often in the years find, wow, there is so many solutions for single problems. But that is really how open source is supposed to work, right? Open source innovation, right? Open source come to us as this permissionless innovation from all the places in the world, right? And then, some project gets some combined, some borrow ideas from each other, and that's how the great solutions became built. And that is what I envision happening in the cloud as well. Now, that doesn't mean I'm kind of Luddite and I'm saying, well, you know what, we should go ditch the cloud, right, and go back to our horse-driven carriages. What I'm saying is what there is a good way to use the cloud as a commodity infrastructure provider, right? It is absolutely fine, fantastic in this way, and you can get a lot of value without have to lock in. What is funny in this case is what a decade ago or so, that is exactly how Amazon used to promote their cloud, right? That is not something I drawn. That is a slide from their presentation which compares there to electricity, right? And one thing we know about electricity, it is commodity, right? You can buy cheaper or more expensive electricity. You can choose that to be green, right, or not, right? But in the end, your fridge will still run, whatever choices you make on that label. But that is not what our cloud vendors want to do it right now, right? With the proprietary services, well, it comes to the situation you have to not only get electricity from them, but also get all your, electric widgets, right? And if you ever want to change your electricity provider, they will stop working. Not a good situation to be in. Well, anyway, back from a general open source and a cloud philosophy to our database and database as a service. With that kind of importance of database as a service and importance in open source space, do we have some good open source database as a service implementation? And I would say, well, not quite yet, but there are a lot of things which are happening, which are enable us to do it in the future. The most important innovation in this space is Kubernetes. Now, how many of you are using Kubernetes in your organizations? Wow, that's a good number of hands here, right? And the wonderful thing about Kubernetes is what that is universally available, right? On-prem, on the edge, you can spin it up on your laptop. It's, of course, available on all the cloud vendors, right? Even folks like Amazon, who initially pushed their own container orchestration system, had to reluctantly, maybe, right, provide us with managed Kubernetes service. And Kubernetes, while it was initially designed for stateless application, it is actually getting better and better for handling stateful applications, including databases. And you can see what the most operators, most open source databases right now have operators, so they can be run at Kubernetes quite well. What is specifically important about that technical concept of operators on Kubernetes is what they are helping you not only with day one, but also with day two automation. Now, what is day one automation? Well, this is like how you deploy stuff, right? Initial configuration. The thing about the databases is what they typically have to live for a rather long time, right? I mean, because we need to have a data preserved for years, perhaps decades, we cannot just, wipe it all, forget everything and deploy it from scratch, right? We need that all the data with all the changes available, right, and probably even be up all the time, right, for serious application. That is why automation of that day two is so much more important and so much more complicated than day one. Within Kubernetes, of course, it provides us a different UX, right? Some people just love it with infrastructure as a code, right? I can just, make changes in YAML file, commit it to the repo, have it automatically deploy. Wonderful. For others, you would prefer more like Amazon's GUI, right, and API experience, which Kubernetes does not provide yet. Though I would think what operator UX is already quite awesome, and I wrote like a quick article about it a couple of months ago. You know, if you haven't spent a lot of time with database on Kubernetes yet, check it out and you'll find, wow, that is actually so much more awesome compared to doing those kind of basic things like scaling backups, right, on your classical bare metal or VM approach. So if Kubernetes is so wonderful, but it needs more work, right, in terms of providing additional GUI for some kind of users, can we build database on a server, database as a service on Kubernetes? And the answer is not only what we can, but what we are actually doing it. If you look at majority of the database as a service solutions, which have been deployed in the last few years, all of them are using Kubernetes in the backend. Some of them are very clear and open about that. Some of them do not really publicize it because, you know what, that is not your business how we run our kitchen, right? But many of them use that, and that means that is possible, that works, that performs reasonably well, right? Because if that would be causing too much overhead, right, well, it would be not economically efficient for those folks to run tens of thousands, right, or more of a database instances. That is also something what we are working at Percona side. We are building that in our open source solutions called PMM. And we expect that to be like one solution of many. I heard about other people thinking about that, right? And my point here is not specifically to pitch Percona product in this case, but to say, hey folks, expect more database as a service solution, open source solution to come in the next few years. From our side, though, you can also check out PMM as it is an open source solution, so you can also have a chance to contribute. And as if any open source project, if you want that project to meet your needs, to make sure the bugs important for you are fixed, engaged earlier, right? Do not wait for that kind of GA release, right, or stable release, whatever you want to call it, because at that point it would be very hard for the development team to do some bigger architecture changes, right? And also, if you folks are not trying Kubernetes yet, say, hey, you know what, I would like to try it out, but don't want to really set it up from scratch. We also partner with a company called Civio, right? So you can spin up a free Kubernetes cluster and play whatever it's operators or database as a service. So with that, well, I hope I answer the question wherever a database on Kubernetes, database as a service as an open source can be done, right? And as many other things, it is really possible, and I think we'll see a lot more wonderful innovation coming from open source database space and open source in general. And with that, that's all I had to say, and I think about now we'll also have an office hours for questions. So thank you.